Good day everyone. Our report is about the life stages of a star. In this report, we will explain how a star is formed, how it changes over time, and what happens at the end of its life. A star does not stay the same forever. It goes through 6 main stages during its lifetime, which we will explain one by one in this report. And these are the stellar nebula, protostar, main sequence star, red giant or red supergiant, death stage, and final stage.
A stellar nebula is a vast interstellar cloud composed mainly of hydrogen gas, helium, and cosmic dust. It is scientifically important because it is the primary site of star formation in the universe. Role in star formation: gravitational collapse. Regions of higher density within the nebula begin to collapse due to gravity. Protostar formation. As the material contracts, temperature and pressure increase, forming a protostar. Nuclear fusion. When the core temperature reaches about 10 million Kelvin, hydrogen fusion begins producing energy. 4. Mainly sequence star. The outward pressure from fusion balances gravity and a stable star is formed. Physical characters. Composition: 90% hydrogen, 10% helium, trace heavier elements. Temperature: very low, 10 to 100 K in star-forming regions. Size: can span tens of hundreds of light years. Types of stellar nebula. Emission nebula. Ionized gas emits light. Example: Orion Nebula. Reflection nebula. Dust reflects light from nearby star. Dark nebula. Dense dust block background light. Planetary nebula. Expanding shell of gas from a dying low mass star, not a star-forming nebula. Importance in astronomy. Stellar nebula explain stellar evolution. They contribute to galactic chemical enrichment. They help science study gravity, radiation, and thermodynamics in space.
Good evening, my name is Dexter from ALS Group 12 Candidates. My report is about photostar. What is photostar? A photostar is the early stage of stars like formed from collapsing clouds of gas and dust, or in short, nebulae. The formation is this. Number 1, gravity pulls together dense lumps within a molecular cloud, causing construction. Number 2, as the cloud collapses, it heats up and spins faster, forming a rotating disk around a central core. Number 3, the core becomes dense and hot enough to emit infrared radiation, making it a photostar. The characteristic: not yet hot enough for a nuclear fusion, the process that powers mature star. Next, emits mostly infrared light, detectable via space telescopes. Next, surrounded by a disk of material that may form planet. Next stage, when the core temperature reaches 10 million Kelvin, hydrogen fusion begins and the protostar become a main sequence star. That's my report, and again my report is about photostar. And photostar na kasama ay ang nebula. Yun lamang po.
Main sequence stages. This is the star's stable longest lived phase, lasting billions to trillions of years, depending on mass. Nuclear fusion and the chaos produce outward pressure that balance in inward flow of gravity, keeping the star's size and temperature steady. Our Sun is currently in this stage about 4.6 billion years. into its estimated 10 billion years main sequence lifespan.
My report is about a red giant. I will explain what a red giant is. A red giant is a stage in the life of a star that happens after the main sequence stage. At this point, the star has already used up most of the hydrogen fuel in its core. Because the hydrogen fuel is almost gone, the core of the star begins to shrink and become hotter. At the same time, the outer layers of the star expand outward. As the star expands, its surface temperature becomes cooler, which causes the star to appear red in color. This is why it is called a red giant. Even though the surface is cooler, a red giant becomes very large and very bright. Some red giants can grow tens or even hundreds of times bigger than the sun. Inside the red giant, hydrogen continues to burn in a shell around the core. In some stars, helium in the core also starts to fuse, producing some energy, or more energy. The red giant stage is one of the late stages in a star's life. What happens next depends on the mass of the star. Smaller stars will eventually shed their outer layers and become white dwarfs, while larger stars may turn into red supergiants.
A superstar giant is the largest and most massive and brightest star in the universe. They are much bigger and more luminous when the star like our sun. Supergiant usually is a late stellar evolution and will end their lives in dramatic explosions called supernovas.
The dead stage is when a star runs out of fuel and can no longer produce energy. For small stars, the star slowly thaws its outer layer, forming planetary nebula. For massive stars, the core collapses and causes a powerful explosion called a supernova. This stage marks the end of the star's active life.
I will explain the final stage of star. The final stage is the last part of the star life. What happens in this stage depends on the mass of the star. For small to medium-sized stars, like our sun, the star loses its outer layer after the red giant stage. These outer layers form a planetary nebula, while the remaining core becomes a white dwarf. A white dwarf is very hot but is small and slowly cools down over time. For very massive stars, the final stage is more dramatic. After becoming a red supergiant, the star explodes in a supernova. After the explosion, the core may turn into a neutron star, or is this core extremely massive black hole. In this final stage, the star no longer produces energy through neutron fusion. It is the end of the star's life cycle.